Okay, this is Unit 6, Lesson 5. Vocabulary review. The LCD of two fractions is the blank of the fraction's denominators. Who has that answer? Jonathan? The LCM, the least common multiple. Very good. Okay, compare, use less than, equal to, or greater than for the following fractions. Who's got number 2? Laura Bell, what'd you get for number 2? You got 5/8 is greater than 3/4. Can you explain to me how you made that comparison?
Because since it has like more pieces than it.
Well, let's think about, can we compare two fractions that don't have the same denominator? If they have the same numerator, we can, but if they don't have the same numerator or denominator, then we can't use our shortcuts. We have to get a common denominator. So how can I rewrite 3/4 so that it has a common denominator with 5/8? What's a fraction that's equal to 3/4 that has 8 in the denominator? 6/8. So is 6/8 greater than or less than or equal to 5/8? Greater than. Okay, we good? Okay, who's got number 3? Question, who had the question? What's your question? If you have another method, we might be even going over it today. Okay, so number 3, who's got number 3? I was about to call, let me call a young man this time. Miles, what did you get for number 3? Greater than, less than, or equal to? What? Equal. And how'd you determine that they're equal? Okay, you simplified 12 and 28ths, and that simplified to 2/7 or 3/7. Okay, how many of you guys did it this way? You rewrote 3/7 as 12/28. Okay, either method works. So Miles, I liked yours. You simplified 12/8 and you got 3/7, or you can rewrite 3/7 as 12/28 and see that they're equal that way. Okay, very good. Who's got number 4? Let me go to a girl this time. Fatima, go ahead.
I got 2/3 is less than 11.
Right, and how did you get 2/3 is less than 11/15?
I multiplied the numerator and the denominator by 5.
Right, if you multiply the numerator and the denominator by 5, you see that this is 10/15, and that's less than 11/15. Very good. And one more person for the last problem, number 5. Let me call on a young man this time. Mr. McDowell, go ahead. 1/6 is greater than 1/12. How did you determine that? You turned 1/6 into 2/12, and that's correct. That's one method. And here we go. 2/12 is greater than 1/12. Okay? Now, Ola was talking about another method. Did you have a question about this problem? Okay. Ola, I think you might have been talking about what today's objective is for comparing fractions. So let's take a look at this. What you'll learn, to test whether ratios form a proportion using equivalent ratios and cross products. Is that what you're talking about? Okay. All right. So, new vocabulary, proportions and cross products. A proportion is an equation stating that two ratios are equal. One method of testing whether ratios form a proportion is to write both ratios in simplest form. Then see if they are equal. That's one method. Okay? So writing ratios in simplest form. Refer to the table. For each class, write the ratio of numbers of students who saw a movie to the total number of students. Do the ratios form a proportion? So can you guys take a look at the chart? Part of this is reading a chart. And we have to figure out if these ratios form a proportion. So here we go. You need to form a ratio for class A and a ratio for class B, and then you need to tell me if these two ratios form a proportion. Really quickly. I see about half the students writing something down, so only half the students are trying to get this. Okay, and my next question goes out to a young lady. Can I get a young lady to volunteer to answer this question? Do the ratios form a proportion? Who can walk us through that? Alexandra, what do we have to do? Okay, so can you give me one of the ratios?
5 to 12.
You got 5 12s. Okay, and that came from what? Which one? Class A. So Class A's ratio is what? 10 to 24. And then you simplify that to 5 12s. Is that what you said? Right. Okay. What about Class B? What was the ratio for Class B? What is it? 25 to 60? Right. And did you simplify that one also? Okay. Is there something we can divide 25 and 60 by? What's the GCF of 25 and 60? 5. So 25 divided by 5 is what? 5. And then 60 divided by 5 is what? 12. So do you guys remember the definition of a proportion? A proportion is an equation stating that two ratios are equal. So are these ratios equal? Yes. So since both ratios are equal to 5 12, the ratios are proportional. So the ratios are only proportional if they are equal in simplest form. Now there's another method we're going to talk about here in a little bit, but at this time what I need you to do is, now that you've seen an example, now I want you to work this out on your own. Do 10 twelfths and 40 56 form a proportion? Down, put your pencils down. Okay, and who's got the answer? Do these form a proportion? Who can explain to the class if these form a proportion? Christian, go ahead.
So for 10 12, I looked at GCF, and the GCF was 2 for 10 over 12.
Okay.
And that would be 5 6.
Okay, very good.
And 40 over 56, the GCF is 8, and that's 5 7.
Okay, so you divided and got 5 sevenths. So what does that tell you about these two? So since these in simplest form are not equal, they are not a proportion. Okay? So here's the key concept. Here's the key concept. Proportion. Ratios that are equal form a proportion. So if we look at that as an arithmetic example, here's what we looked up. 6 eighths equals 9 twelfths. So we can simplify both of these to 3 fourths. This simplifies to 3 fourths. This simplifies to 3 fourths. They form a proportion. So the algebraic way we're going to represent that is A over B is equal to C over D, so long as the denominators B and D do not equal 0. And we talked about division by 0 or fractions where the denominator is 0. That's not allowed. That's not defined. Okay. For two ratios, the cross products are the two products found by multiplying the denominator of each ratio by the numerator of the other ratio. So I try to color code this. So here's my example. So 6 eighths is equal to 9 twelfths. And since they're equal, they form a what? What's the new vocabulary word? Since these ratios are equal, they form a proportion. Now, the way we can check it, this is the other method. We know that two ratios form a proportion if the cross products are equal. So Cross product meaning this numerator times this denominator, so 6 times 12, and this numerator times this denominator, 8 times 9. Okay, well, 6 times 12, what is that? 72. Does everybody agree? And so if this 6 times 12 is 72, is that equal to 8 times 9?
Yes.
Yes. So these are a proportion. Does everybody understand cross product property? That's what we're talking about in the key concept. That's what we just demonstrated. A proportion is an equation that states two ratios are equal. One method for testing whether ratios form a proportion is to write both ratios in simplest form, then see if they are equal. That's what we just did. The other method is the cross product.
They're both right?
So 2 methods to do that. Now, key concepts. Cross product property. If 2 ratios form a proportion, the cross products are all equal. If 2 ratios have equal cross products, they form a proportion. So here's our arithmetic example that we just worked out. And then algebraically, it's the same as earlier. 2 ratios are a proportion if they are equal and the denominators do not equal 0. That's undefined. Okay, so now that we've seen the second key concept and the last key concept of this lesson, moving right along, we're going to use cross products to test these 2 sets of ratios. Test these out, use the cross product. I need you to try, write it down, try it so you'll remember it. You learn by doing, you recall by doing, not by watching. Can I get somebody to explain to me the first problem? Is 5/9 and 30/54 a proportion? So let's work that one out first. Who can explain that to me? Somebody I haven't heard from yet. Villatoro, go ahead. So walk me through the process. What's the first thing I need to do?
I started with 5 times 54.
Okay. 5 times 54, and what else are you supposed to find the product of? 9 times 30. So this is the first step. Okay, so what did you get?
I got total 270.
You got 270 for both of them? So what does that mean? It means that the 2 ratios are form a proportion. Okay, so over here, next problem. Who's got the next one? Logan, can you go ahead and walk me through this one?
7 times 65
And what else?
and 55 times 8.
Very good. And what did you get when you took those products?
I got 55 times 8 is 440.
Okay. And what about 7 times 65?
378.
378, is that what you guys got? Who got something different? What'd you get?
65 times 70 was 450.
Okay, 455, so maybe you didn't carry something. But your result would have been the same. Do they form a proportion? No, and why not?
Because they're not equal.
Because their cross products are unequal. The 2 ratios do not form proportion. Pretty easy? Okay, let's move along. I got 3 more for you to do, these 3. These are a little bit easier, smaller numbers. Work them out. Great, I see a lot of hands. You are anxious to answer, but I want you to write these out. Somebody you haven't heard from yet? Joshua, can you walk me through the first problem? Okay, so you multiplied 8 and 6 and 3 and 16, and then you told me that those products gave you 48 for both. And so what does that mean if their cross products are equal? That the two ratios form a proportion. Okay? Who's got the next one over here? Somebody I haven't heard from yet. Fatima, go ahead.
I multiplied 9 times 4, which
Okay.
got me 36.
So 9 times 4 gave you 36. What else did you multiply?
And 6 times 6 also got me.
And 6 times 6. Okay. Which also got you 36. And what does that mean? Not that they're equal. Well, it means, what else does it mean? What's the vocabulary word we're trying to learn today? Shh. If your name's not Fatima, I need you to keep quiet. So if the cross products are equal, what does that tell us about the two ratios? If the cross products are equal, the two ratios form a proportion. Okay? And who's got this last one? Somebody else I haven't heard from yet. Caleb, I haven't heard from you. Go ahead.
So, this one, 4 times 9 equals 36.
So you're multiplying 4 times 9, you got 36. And what else?
5 times 8 equals 40.
Okay. So you get 36 and 40. And if they're not equal, what does that tell us?
It's not proportional.
They are not proportional. They do not form a proportion. Since the cross products are not equal, 4 eighths and 5 ninths do not form proportion. Okay, any questions? Pretty easy? Okay, moving along. Here we go. A proportion states that two blanks are equal. Who can answer this question? Somebody I haven't heard from yet? Rudy. A proportion states that two what are equal? Two ratios, very good. Okay, number sense. Without writing 3/5 and 9/5 in simplest form or using cross product property, how can you tell whether the ratios form a proportion? Timothy, what do you got? You multiply, what'd you multiply by? 3 times 15? Well, if you multiply 3 times 15, that's 45. How's that going to help us out? Because what? No, they said not to use cross product property. You need a different strategy. Jonathan, what's your strategy that's different? 3/5 is equal to 9/5? How? Very good. So, if you multiply the numerator and the denominator of the first fraction by 3, you get the second fraction 9/5. Very good, Jonathan. Okay, filling in the blanks so that each pair of ratios forms a proportion. What do I need here so that these two ratios form a proportion? Somebody I haven't heard from, Terrell. 8, very good. What about this one? What needs to be in this box here so that these two form a proportion? Olamide? 9, very good. What about this one right here? What needs to be in that box so that these two form a proportion? Abu?
It would be 9.
9 again, yes. In this set of ratios, what needs to be in this box for these to be to form a proportion? Somebody I haven't heard from. Tayana? 14. Very good. Over here, for these set of ratios, what needs to be in this box for these two to form a proportion? Somebody I haven't heard from. Miles? What needs to be in this box so that these two ratios are a proportion? 6? What? 12? Yep, very good. And then the last one, who's got the last one? Amani. What needs to be in this box so that these two are proportions? 3? Correct. And the last one, error analysis. Let's take a look at this one. A student used the cross product property to determine that 3/4 and 12/16 do not form a proportion. His work shown at the right. Is he correct? Is this person correct? Who can? I'm hearing yes, I'm hearing no. Shh, raise your hand, and I would like to hear from one person explaining this. Alexis, go ahead.
I think he's wrong because if you use kind of what we did before
The cross oh, okay.
without the cross, you can multiply the first fraction by 4 and you get like the next fraction. So if you multiply 3.
Okay, so you're not using cross product and you're not simplifying, but they want you to identify where he made a mistake. Where's his mistake at? Can I get Joshua? Go ahead and explain to us. Where's his mistake?
His mistake was he didn't use cross product.
Why didn't he use? What didn't he do in cross product?
He didn't multiply 16 and 3 and 12 and 4.
He needed to multiply 16 and 3, so this numerator to this denominator, and he needed to multiply 4 and 12. So do these form a proportion or not?
Yes.
Yes. Why? Because the cross products would both equal what? 48. Very good. Okay. Any questions?